In this lesson, we'll continue to look at methods for solving non-right angle triangles by considering the cosine law. In the previous lesson, we considered the sine law, and you'll recall that the sine law is expressed in either one of these two forms, and that to use the sine law, you need to be given 1.5 side angle pairs, where a side angle pair is a side and the angle opposite it. The cosine law works in cases where we can't use the sine law, specifically if we're given two sides and the contained angle, meaning the angle in between the two sides, or if we're given all three sides of a triangle. Using the same naming system where capital letters are angles and lowercase letters are the sides opposite them, the cosine law is often expressed in this form. C squared is equal to a squared plus b squared minus 2ab cos c. It's easier to remember that by thinking about the pattern that it makes around the triangle. We've got two sides and the angle in between them, and we're trying to find the side length opposite. So the side length opposite is equal to one side squared plus the other side squared minus 2 side cos of the angle in between them. It's easier to remember that pattern rather than trying to name the angles. Sometimes you'll see textbooks give these alternate forms. All that's doing is shuffling which angles are the angles we're given and which sides are the sides we're given. It's easier just to remember the pattern. Another thing to remember is that the side and its corresponding angle are at opposite ends of the equation, and that can help you remember it as well. It's actually easier not to write out the cosine law with the letters in it, but just to jump right into subbing in the numbers. Let's take a look at an example. Here we're asked to solve for this side a to 1 decimal place. So a is our unknown, and a squared is going to be equal to one side that we're given, 4 squared, plus the other side we're given, 7 squared, minus 2 times 4 times 7 cos the angle in between them, which is 62 degrees. Working that out, we get a squared is equal to 16 plus 49 minus 56 cos 62 degrees, and therefore a is equal to the positive square root of 65 minus 56 cos 62. And it's usually best to let your calculator do as much of this work for you as you can to avoid having to carry things through. If you plug that in and work it out, you get that a is approximately equal to 6.2. So that's an example of using the cosine law to find the side opposite when we're given two sides and the contained angle, or the angle in between them. Here's another example. We're asked now to solve for an angle B to 1 decimal place. Now if we want angle B, that means that we're going to have cosine B at the end of our equation. Therefore, B has to be the side opposite. So we want to put 5.2 squared on the opposite side of the equation. 5.2 squared is equal to 3.4 squared plus 4.7 squared minus 2 times 3.4 times 4.7 cos B. Working that out, we get 27.04 is equal to 11.56 plus 22.09 minus 31.96 cos B. Bringing these to one side, negative 6.61 is equal to negative 31.96 cos B. Dividing both sides by negative 31.96, we get that cos B is equal to this quotient, and therefore cos inverse of that quotient, we can drop the negatives because they cancel, is going to be equal to B. Plugging that into your calculator, you get that B is approximately equal to 78.1 degrees. So that's the way that you can solve for an angle using the cosine law. And there's no ambiguous case of the cosine law. When you're given the information that the cosine law requires, you're only ever going to be able to solve it in one way. Now let's look at an interesting situation that arises when the contained angle is 90 degrees. So in this diagram, let's make C our contained angle in question, so it's 90 degrees. Now if we let C be 90 degrees and just leave the rest of the sides as variables, we get C squared is equal to A squared plus B squared minus 2ab cos of 90. And you'll recall that the cosine of 90 is the x value on the unit circle when our principal angle is 90. So we're up here, and the x value of that point, 0, 1, is 0. So cosine of 90 is 0. If this is 0, this whole thing will become 0, and we just get c squared is equal to a squared plus b squared. And you'll recognize that as the Pythagorean theorem. So the Pythagorean theorem is really a special case of the cosine law, which occurs when the contained angle is 90 degrees. So that's the cosine law.